Hi. Well, what we're going to look at is 5.1 and 5.2 in this video, and it's going to be about exponents and the rules involving exponents on variables. And then we'll use these in the next couple of sections, or actually for the rest of the semester. All right, so to begin with, let's look at some examples with powers. So we have, what does the expression a cubed mean? So this is read a cubed. It's not wrong if you say a to the third, but this is read a cubed most of the time. Let me put a little bit, the cubed. Okay, now what does this mean? A lot of people will take a times 3. It's something you do not want to do. So this a cubed means that you're taking a times a times a 3 times. A times itself 3 times, not 3 times a. There is a difference. So as an example, if we had, let's say, 3, not 3, how about 5 cubed? Keep the numbers a little bit different. There are many people that would write 15, but that is not correct. So make sure you don't do that. It does not mean 5 times 3. What it does mean is 5 times 5 times 5. So, excuse me. So 5 cubed means 5 times 5 times 5, which is 125. Now, this right here is called exponential form. So you're writing it using an exponent. This would be expanded right here. And this would just be simplified to see what it equals. All right, so you've got your exponential, you have an expanded form here, and then you have just simplified. Pay attention to what Pearson wants, because if they want exponential form, it will count this wrong and this wrong. All right, even though they're equal, it wants the right form, which would be 5 cubed. So now that we know that a cubed, I'm going to put a little a cubed up here. Can't see the cubed, so let me rewrite it. All right, is equal to, I'll just put it over here. So a cubed is equal to a times a times a. What about a squared is how we write that now, or read that. It could be a to the second, but most of the time, 99% of the time, you read it a squared. A squared. And what does a squared mean? It means a times a. You have 2 of the a's multiplied together. So as an example, if we had 5 squared, it's 5 times 5. This is exponential form. Then we have an expanded form. And then this is equal to 25. Many people would have put 10, but don't do that. It's 5 times 5. All right, now what happens, and this is what our first rule that we're going to talk about, what happens if we want to multiply these two together? So I want to take this, a cubed times a squared. Here again, a cubed times a squared, using the expanded form to kind of explain the rule for this. A cubed is a times a times a times, so we have that times there, a squared, which we know is a times a. What does this equal? We have 1, 2, 3, 4, 5. A to the 5th. We're multiplying 5 of these a's together. So this is equal to a to the 5th is how we read that. We only have a special word for the cubed and the squared. Otherwise, a to the 5th, a to the 6th is how you say that. So again, no one wants to write these out and then count them. So we have a rule called the product rule. And the product rule says for any number a and any integer m and n, given these, when you're multiplying, now this is a key, is that the bases have to be the same. What do I mean by the bases? These variables here have to be the same. Or if they can be a number too, and we're going to look at some examples. But when the bases, this is called a base, these down here, the bases are the same, and you have these exponents, you add the exponents when you're multiplying common bases. When you're multiplying common bases, you add the exponents. So if you look back up here, a cubed times a squared, these are the same. So you could have gotten the same answer without writing out 3 of your a's and 2 and saying, okay, I'm multiplying 1, 2, 3, 4, 5 together. You can just take 3 plus 2. So when you're multiplying common bases, you add the exponents. And again, this is underlined, the same base. And we'll look at what happens when we have multiple bases. It's not that hard. All righty. And again, these rules themselves are not hard, and we'll be going over 3 of them. It's just a matter of when do you add? When do you multiply? When do you subtract? We don't ever divide exponents. All righty. So let's go ahead and let's look at some examples. Looking at this first one, 2 to the 3rd, 2 to the 8th. The bases are the same. So the base is a 2. So you write that common base down. Again, here's an issue. Some people want to put 4. They actually want to multiply the bases together, but you don't do that. All right, we have a common base of 2, just like we had a common base of A. All right, and we just wrote an A. Now you add the exponents. When you multiply, you add the exponents. 3 plus 8, so 2 to the 11th is your answer. And a lot of times they'll just want it in exponential form. And the reason being is that when you start getting these here, like 2 times 2 times 2 times 2 times this, you're multiplying 2 11 times, the numbers get pretty high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so you have 11 of those 2s. And with this exponentials, the numbers do increase quite a bit, very, very quickly, and become very large. And so you can just leave it like that. Okay, let's look at another one. Again, we have a common base of 5. So you write that common base down, and then you add the exponents. But here's something you need to remember. That first one, there's no exponent there. So what we do is we don't write them in, but there is a 1. It means you've got 1 5. So you may want to write that in just so that you don't forget. Now we add the exponents. 1 plus 8 plus 3. So that gives us 5 to the 12th. Again, very large number. So we'll just write it in exponential form. 5 to the 12th. Let's look at the next one. We do have a common base. It's a little bit more complicated, but both of these, this exponent has this base, and this exponent has the same base, r plus s. So we'll write it down. And you do have to use the parentheses. You have to have the parentheses. And then you just take 3 plus 8. So then I'll go ahead and write this out. 3 plus 8, r plus s to the 11th. So I'm going through this fairly slowly, just in case it's been a while for some of you. And so this would be your answer. Okay. Now let's look at this one. Now we have 2 different bases here. We've got A's and we have B's. It's all multiplication. There's no addition or subtraction. The addition and subtraction we're going to do in the next video when we talk about 5.3 to 5.6. But here there's no addition and it's all multiplication. So we look, parentheses means multiply. So we've got A and an A. I'll come back and talk about the coefficients in front. I have a common base of A, so then I take 3 plus 3. And I'll do that here. Okay, and that gives us A to the 6th. I'll just do that right times, and I'm just going to put a dot there for times. You can use parentheses or nothing at all. I have another base of b, and it has a 2 plus 5, which is b to the 7th. Now, rather than put a multiplication or a parentheses, we just write them next to each other because we know that in algebra, anything next to each other, you multiply. Oh, sorry, 7. Why I put a 5? So that, oh my goodness. Sorry about that. Get it? 7. All right, so you've got b to the a to the 6th, b to the 7th. Now, the numbers in front, there are times when they'll put a number in front, and we're going to go ahead and talk about that right now, and then we'll do some more practicing later. As an example, let's say I had 3xy cubed times 2x squared y to the 4th. All right, let's say we were multiplying that because now we've got these numbers in front. And if you'll notice on D, there weren't. And so here, well, there are numbers, we just don't write them in, they're ones. But here we take 3 times 2. So they're called coefficients, and we'll be talking about that as well in the next section, in the next video. But you multiply these numbers that are in front that are not exponents. The 3 and the 2 are not exponents. So we can multiply those together and get 6. And then we have x1 plus 2 is 3. 3 plus 4 is 7. So if you do happen to have numbers in front, which we call coefficients, you multiply those together. Going back to this one, the coefficients are actually a 1, because just like we don't put the 1 in for our exponent, we don't put the 1s in front. So you're taking 1 times 1, which is 1. All right, so we just don't put that 1 in. Okay, so if you're multiplying, let's repeat this rule. If you're multiplying common bases, you add the exponent on those common bases through these steps here. Now, what happens in division? And that's what we're going to look at our next rule at the bottom of this page. The quotient rule, quotient meaning the answer in division, and product meaning the answer in multiplication. Maybe a little bit of review of vocabulary here. When they ask for the product, it means you're multiplying. If they ask for the quotient, let me move this up. Try there. All right. If they ask for the quotient, it's a division problem. They're asking for the answer in your division problem. Now, for any non-zero number A and integer powers m and n. Now, what they might do is they may say that A does not equal 0 on the side. They'll have a comma there. Well, what this means is that in mathematics, and this is what calculus addresses, is that we cannot have a 0 down here. That's all that's saying. It's just giving you some information about the problem. So, for most of your cases, you can just ignore that. And just know in the back of your mind that A cannot be 0. So they're limiting the domain, knowing that the denominator cannot be 0. That's all they're doing. But really, it has nothing to do with solving the problem itself. Okay, so when you're dividing, okay, it tells us what we're going to do is we're going to subtract the exponents. As an example, if I had a to the 5th over a squared, we know that a to the 5th is a times a times a times a times a. Yep. And then in the denominator, we have a times a. We have 2 of those being multiplied together. Now, going back to fractions, I know that these will cancel here and here. And so you're left with a cubed. A cubed, because you have 3 of these a's left. Instead of writing this out expanded, you can go back to the exponential form and subtract your exponents. 5 minus 2 is 3. Now this has, you know, a little bit of, there might be a few examples here that we'll have to go through as far as, do we know if this is in the numerator or the denominator, but we'll look at that when we look at some examples. Okay, so again, product rule, when we're multiplying, we add exponents. When we're dividing, we subtract the exponents. So let's look at some examples of this. Staple them together this time. All right. Well, it looks pretty much like most of these are larger. Okay, so here we have 8 x's in the denominator, excuse me, in the numerator, and we have 2 in the denominator. So x to the 8th in the numerator, x squared in the denominator. So these bases are the same, and we're going to put the x. Now the x, for most of the time, will go in, it will go where the largest exponent is. So we know that we're going to have more in the numerator for our answer if we were to cancel them. So we have 8 minus 2 in the numerator. I'm not going to put it over 1. I guess you could put it over 1, but, and we end up with x to the 6th. We won't make it too complicated yet. All right, let's look at the next one. Common bases. So you subtract exponents. 9 minus 4 is 5. 7 to the 5th. So we took 9 minus 4. I did not write that out to get the 5. X to the 5th. Okay, now let's look at C. C, I have these parentheses, and it's kind of like the other one that we had, the R plus S. So we've got the 5a to the 12th power and the 5a to the 4th power. So what we'll do is we'll have 5a, and you do need to use the parentheses, to the 12 minus 4, which is 8. All right, 12 minus 4. I'll put that right there to see where the 8 came from. So again, you do need to keep the parentheses. Okay, well, let's look at D here. Now, D, I've got these coefficients in front, and I know, just like we did the example where you had the 2 times the 3, now we're going to reduce the 4 and the 6, just like a regular fraction. All right, they don't have that common base to do anything with the exponents. 2 goes into both of them, or your calculator would reduce it for you, and you get 2/3. Okay, you divide them both by 2. Now, we have p to the 5th and p squared. The largest one, which is p to the 5th compared to the p to the squared, is in the numerator. So I put my p there. Okay, and I take 5 minus 2, which is 3. Q's, again, the largest amount is in the numerator. So I'm going to put the Q there. 7 minus 1. So that's a tough thing. You've got to remember that if it's not there, there's a 1. So you get to the 6th power. All right. So hopefully this is kind of making sense here. Okay, I had to stop the recording for a second. All right, so looking at this here, again, this is a key. 7 minus 1 is the 6. You've got to put the 1 in here. If there's nothing there, it means there's a 1. Now, given this, all right, there's different ways of writing this. This is not wrong. You could also write it like this. All right, so 2/3 p cubed, q to the 6th. Either one is right. All right, I don't think Pearson would count either one wrong. So just to kind of be aware that this and this mean the same thing. All right, Okay, so now we've talked about our two rules: product, multiplying, you add exponents, and division, you subtract the exponents. But now we're going to talk about zero. Here, zero, as I was just kind of reading this right here to see if I wanted to talk about this. In both of the cases above, you need to make sure to keep the base the same. Do not multiply or divide the base numbers together. And what they're talking about here in this box is number 7. Is that, or excuse me, is B with the 7 here. So you don't make, if you were multiplying, you wouldn't make it 49, and they're not going to cancel each other out. So you just keep it the same and subtract the exponents. So when you're dealing with the exponents, keep the base the same. All right, that's kind of what that box there means. Okay, 0 as an exponent. So here we're going to actually use the, we know that if we have, I'm going to use another example than a to the 4th over a to the 4th. Okay, if we have 5 over 5, we know that that's equal to 1 if you reduced it. 3 over 3 is equal to 1. X over X is equal to 1. All of those are equal to 1. Now, if I had a to the 4th over a to the 4th, here I know, looking at these examples, when these match, they cancel each other out, it's equal to 1. But using our rules of exponents, when the bases are the same, I subtract the exponents. So I would take a to the 4 minus 4, which is a to the 0, which tells us, all right, these two mean the same thing: common base, subtract exponents, and it's equal to 1. And they match here, we know it's equal to 1. That tells us that a to the 0 is equal to 1. So anything to the 0 power is equal to 1. And that can simplify some of the problems in the homework. So let's go ahead and look at this idea, knowing that a to the 0 is equal to 1. We know that a to the 0 is equal to 1. Because when you subtract exponents, you still end up with a 1. So here, make sure whenever you have anything to the 0 power, it's 1. So let's look at a. Let me move this up just a smidge. 1948 to the 0 power is equal to 1. It's that simple. Anything to the 0 power is 1. -9 in the parentheses to the 0 power. 1 plus 2. Just 3. All right. The 2 is not a part of the 0 power, so it just stays. Looking at this right here, 3x in the parentheses, it means both of those are to the 0 power. Everything in the parentheses is to a 0 power. So it's equal to 1. D and C are very different. Without the parentheses, the only thing with a exponent is the x. The 3 is not a part of the 0 power any longer. Without the parentheses, the 3 is not a part of that 0 power, which means it's 3 to the 1st, it has a 1 there, times x to the 0 is 1. So without the parentheses, only the x has a 0 exponent. Without them, only the x. Here in the parentheses, they both have a 0 exponent. So the answer to this one is 3. All right, which is kind of tough. You just something that you're going to have to work on and do a lot of examples. Let's do one more example. If I had 5x to the 0 or 5x to the 0. This is 1 to the 0. Well, excuse me, just 1. not 1 to the 0, even though they mean the same thing. All right, so this would be 1. Anything in the parentheses to the 0 power is 1. Here, the 5 times, it's not a part of this exponent, it's 5 times this right here. So 5 times 1, which is 5. So try to remember to recognize the difference between the two. Okay, let's look at E. We have -1 times 9 to the 0 power. This means -1 times 1. -1 times 1 is a -1. Another way of writing E is without this -1 in the parentheses is this right here. So E and F mean the same thing. Generally, we just have the subtraction in front, the negative in front, this negative. So here, this would be negative. The negative is not a part of the 0 power. It's not in the parentheses. So this gives us -1. Otherwise, if I want the negative to be a part, I have to put it in parentheses. Now it's a part, and this is a positive 1. Here, the 9 to the 0, and then this negative is not a part of that 0 power, so it stays. This is another way of writing this right here, a -1 times 9 to the 0. All right, so again, recognize the difference between these. If you have parentheses, all right, then the negative or everything is a part of the 0 power, or whatever power you happen to have. Here, only the 9 has the exponent. And you don't include your negative in front. Okay, great. Look at another. Our third rule here deals with raising a power to a power. This is our last rule. So sometimes we add when we're multiplying exponents. When we're multiplying bases, we add exponents. If we're dividing common bases, we subtract exponents. And now our last one is when you have a power to a power, you multiply the exponents. And so here is kind of a general rule for that. So then we'll multiply the exponents. Let's look at some examples. Again, m squared to the 5th power. What this would be equal to is m to the 10th, because you take 2 times 5, you multiply those together, m to the 10th. I'll write it down here. Now here, a couple of ways you could do this. You could simplify inside, and we'll be looking at that later. You could simplify this inside first, and anything to the 0 power is 1. Okay, and then 1 times 1 times 1 times 1 times 1 times 1, 6 times, is just 1. Or going back to this rule of multiplying these, if I 0 times 6 is x to the 0, because 0 times 6 is 0, anything to the 0 power is 1. Now, notice that I dropped the parentheses when I multiply those. I dropped the parentheses. Okay. Here, when I multiplied those, I dropped the parentheses. Here, I didn't multiply, so I kept the parentheses. Okay. All right. Either way, you're going to get 1, whichever way seems easiest to you. This one would be easier just to multiply, these together. 3 to the 6 times 0. 6 times 0 is 0. Notice I'm just keeping the 3 there. Anything to the 0 power is 1. So we've kind of incorporated looking at the 0 power again, and then when you have a power to a power, right? What you do with the exponents when you have a power to a power. But let's keep working on that idea, the power rule, some more. Let's look here. Again, 2a in the parentheses cubed. What does this mean? We're couple ways we'll do the expanded. Everything in the parentheses, you have 3 of those and you're multiplying them together. That's what that means. And again, we're not going to use the power rule right now. We're going to use the product rule. So 2 times 2 is 4, times 2 is 8. 1 plus 1 plus 1. With the product rule, you add the exponents. 8a cubed. Another way of doing that, instead of writing it in expanded form and thinking of the product rule, you'll expand this using the product rule always. Here we could use our power rule. Given something like this, first off, you take 2 and you cube it. All right, we're not dealing with the exponents here. We're not dealing with exponents. So you take 2 and you cube this and you get 8. 2 times 2 times 2. And some of these you can use your calculator. This gives you 8a. Now again, this is a 1. You know, something that, you can't forget is that when there's nothing there, there's a 1. 1 times 3. So you will multiply these two together. So you'll take 1 times 3, which is 3. So again, here's an expanded form, and here's using our power rule, which is easier in some cases. All righty. What happens if we have more than one variable inside of a parentheses, or if we have a quotient in a parentheses? Well, given something like this, you deal with these individually. You would take the exponent on the a, which in this case is a 1, times n, and then the exponent on the b, which is a 1, times n. So you get a to the n, b to the n. So again, you multiply them separately, the exponents. And again, even with a quotient, you multiply the exponents separately. 1 times n is n, 1 times n is n. So you do those separately. So let's look at some examples of that. All right, looking at this, you take 4 and you cube it. So 4 times 4 is 16, times 4 is 64. I'm going to see if I can focus that a little bit. Okay, great. We have 64a. Now on the a inside is a 1. 1 times 3 is 3. So 4 cubed, again, it can be done on your calculator using your caret key if you have a scientific calculator. And that would tell you that you get 64. And then you just multiply these powers here. Okay, let's look at B. This brings us to an important idea. Inside the parentheses, I have a -5, which will have to be squared. And I have an x to the 4th. It's going to have to be squared. Let's talk about the -5. Whenever you have a negative and you have an even power, all right, inside the parentheses, it will be positive. All right, so if what we're doing here, looking at the expanded form, -5 times a -5, we know that a negative times a negative is a positive. So that gives us a positive 25. -5 squared means this. So whenever you have an even number of negatives, it will always be positive. If you have an odd number, it stays negative. Okay, let's see. There aren't any examples of that, so we'll make one up here in a second. So when you have a negative inside the parentheses and it's an even power, it will be positive. On your calculator, you have to be very careful that you don't take -5 squared, but a -5 in parentheses squared. It goes back to that idea with the 0 power with our 9. Here, it's only the 5 that's being squared, not the negative. So the answer here is a -25, and that's exactly what your calculator will tell you. But if it's in parentheses, make sure you put it in parentheses and you get a +25. So just something to always be aware of, that when you square a negative number, make sure you put it in parentheses, or to the 4th power or the 6th power, or whatever power you're using. If you have a negative, you need to use parentheses, or the calculator will make it negative. And it's right, it's a -25 without the parentheses. So going back to this one, I know that a -5 squared is a +25. X, 4 times 2 is 8. So you get 25x to the 8th. Positive, because the negative is inside of the parentheses, and that's an even power. Okay, kind of talked about a couple of important concepts there. Let's look at C. There isn't a number in front, okay? So it's actually a 1, but 1 squared is 1, because 1 times 1 is 1. So we just kind of ignore it. Now here we'll have A, 7 times 2. I'm going to go ahead and write that out. B, 3 times 2. So you're multiplying power to a power. So your answer is A to the 14th, B to the 6th. All righty. Let's look at D. What do we got here? We have a couple of things going on. We have an exponent, and then we have a multiplication. What we do is we do PEMDAS. And in PEMDAS, I'm going to write it way down here so I have enough room. Exponents, the E comes before multiplication. So we're not going to multiply these. We're going to do the exponent first, and then we're going to multiply. We'll follow the rules of order of operations. So we have 7 times 2. I think I can put it over here. A to the 14th, B to the 2nd. So I multiplied 7 times 2 and got 14, 1 times 2 and got 2. Now the other one doesn't have an exponent, so I don't need to do anything. I'll just copy it. Now we use our product rule. We add exponents when we have common bases. So 14 plus 3 is 17. 2 plus 4 is 6. So we did our power to a power first using multiplication, and then using the product rule, we added exponents when the bases are the same. All right, let's go to another one. E. Both the X is in the parentheses and the 5 is in the parentheses, so they're both being squared. Here we'll have X squared. Why? Because this is a 1. And 1 times 2 is 2. 5 squared. All right, 5 squared, we're going to simplify it. We'll get 25. All right, so they'll actually want you to multiply for the most part here, you know, these basic ones, unless they say exponential form, they'll want the 25. Because really you're taking 1 times 2 and getting 2, but we simplify it and get this. All right, let's look at another one. Here we have a 1 and we have a 4. 1 times 3 is 3. 4 times 3, 4 times 3 is 12. Power to a power, you multiply. But here, Pearson will want you to probably have that as a number. Get that? Okay. You know, sometimes it's just hard to remember, when do you add? When do you multiply? When do you subtract? And again, one of the hard things is also remembering that if it doesn't have a power, you put a 1 there. All right, let's look at another one. And then we'll practice these with some examples. Okay, looking at this, we have 3 squared. All right, so we've got 3 squared. 4 times 2 is 8. Now the 3 squared, some of you will just put 9, and that's fine. 3 squared, just put 9. 3 times 2 is 6. So 9, a to the 8th, b to the 6th. So we're multiplying the exponents, and then we are simplifying the number values. Unless they say keep it in exponential form. All righty, let's do some more examples down here. Just a few more, just to practice. Maybe you got it. You moved on to the homework. That's great. Here, we're not going to do anything here. We're going to take care of our exponent because of the PEMDAS. We're going to do exponents before we multiply, which means we'll leave the first one alone. And we'll have a to the 20th, b, there's a 1 there, 1 times 5 is 5. So we did the exponent. Now we'll multiply using our product rule. 8 plus 20 is 28. 3 plus 5 is 8. And there you have your answer. Let's do another one. Here we've got, I might just draw a line here. 8 and 2. Okay, how does that reduce down? Well, 2 goes into both of them. 2 goes into their 4. 2 goes into their 1. Now, if you end up with just a 1 in the denominator, you can ignore it. You don't have to put it in there. And in fact, Pearson may count it wrong if you have just a 1 and you include it. Let's go ahead and do our A's. 9 minus 2 is 7. B, 7 minus 1 is 6. So because there's just the 1 down here, it's 4a to the 7th, b to the 6th. We don't need that. All right, let's do another one. Here, looking at this, I do know that this right here is a 1. It's gone. It's just a 1. If you didn't recognize this, 9 minus 0 is 9. Okay, so either way, you're going to end up with just m to the 9th. N, 8 minus 4 is 4. That's it. You're done. Let's do another one. Again, there's nothing to really do as far as reduce down inside. I always try, if there is some reducing that can be done, I try to do it before I do the exponent. So I try to do the parentheses, which is the first one of PEMDAS. So if it can be reduced, I look to see if it can be. Otherwise, I'll go to exponent, which is what we're going to do right now. We have x. 2 times 4 is 8. 1 times 4 is 4. We have a z in the denominator. 3 times 4 is 12. It's going rather quickly. Let's look at the other one. All right, this one has a negative in the parentheses, and we kind of talked about that earlier, that if you have a negative in the parentheses and it's an even power, it becomes positive. The answer will be positive. But this has a negative, and we have an odd power. What does that mean? It means that the negative stays. Now, where you put that negative doesn't matter. It can be here in the middle. It can be here or here, as long as you have the negative somewhere. So I looked at this, I thought, oh, okay, I've got this negative and cubed, so I'm going to keep the negative. 5 and 2 do not reduce. If you want to keep the negative with the 2, go for it, it's fine. If you want to move this down to where it was in the original, that's fine. Oops, sorry, I forgot to cube them. So we'll do that right now. 5 cubed is 125. 2 cubed is 8. And it's negative because it's an odd power out here. So the negative stayed. Now let's go to our exponents. We have 7 times 3. So we have x. 7 times 3 is 21. Y. 1 times 3 is 3. Z. 4 times 3 is 12. There you go. There's your answer. That's as far as it can be reduced. It's kind of a little sloppy here. These should be next to each other, but it's okay. I think you get the picture. All right, let's look at another one. Last one. And then we're going to look at the next section, 5.2 with negative exponents. Here, I have a negative, and this is odd. So I know my answer, the negative stays. If that had been a 6 or a 4 or a 2, it would have been positive. The negative would have gone. 4 and 3 do not reduce, so I'll just go to my exponents. There's nothing to reduce inside the parentheses. All right, so 4 cubed is 64. 4 times 4 times 4. You can use your calculator, or 4 and use your caret key to cube it. P, now we multiply exponents. 8 times 3 is 24. 3 cubed is 27. Exponents, 2 times 3 is 6. 3 times 3 is 9. And there's your answer. All done. Okay, now let's go ahead and we're going to look at section 5.2. I wanted to do these together so I didn't have a whole bunch of videos. All right, this is dealing with negative and exponents in scientific notation. Most of you are pretty familiar with scientific notation, but we'll briefly review it a little bit here. And this scientific notation incorporates the negative exponent. Okay, so what happens here is that we have this negative exponent, and the negative exponent has a job. And what it does is it changes the position of the base. So if I have, let's say a to the, okay, let's keep it -7. This is equal to, if it's negative in the numerator, you can change it to be positive by changing its position. So the negative exponent, think of it as a position changer from numerator to denominator. And that's all it does. There are some people that would like to change the sign on the base. That's not what this negative exponent does. It just changes the position numerator to denominator or denominator to numerator. Let's look at another example. If I had 1 over a to the negative 2, this is equal, it's negative in the denominator. So if I wanted to get rid of the negative exponent and write it just positive exponents, to get rid of that, I have to change the position from denominator to numerator. A squared over 1, or just a squared. So it's a position changer. It doesn't change the sign on it, doesn't make it a negative, doesn't make it a negative, it just changes positions. And here they kind of give you a general rule. A to the negative n, if you want to get rid of the negative exponent, you have to change the position of the base. Numerator to denominator, or denominator to numerator. And once you move it, the negative disappears. It becomes a positive exponent as soon as you move it. All right, well, let's look at this idea here. M to the negative 3. Well, m to the negative 3, they want you to express using only positive exponents. So, and then simplify if possible. It's in the numerator. This could be considered over 1. So if I want to get rid of that negative, I simply move it to the denominator and it becomes positive. Change the position. That's it. This one right here, it's in the numerator. It's over 1. So if I want to make it positive, okay, I change it from the numerator to the denominator, and then it becomes positive as soon as you change the position. But they also want us to simplify. So they actually want you to square the 4 and get 16. Okay. All right, let's keep doing some examples. Here we have a couple of things here. Oh, I was looking down at this one. This one right here, the negative, all right, is in the parentheses. Whenever you have an even power, it will become positive. So I know that that negative is going to disappear. And it's going to disappear because that's an even power. 2 is even. So you can get rid of this and then square it, or you can square it and then flip it. The order, you can get rid of this and move it like we did here and then square it. All right, and maybe we'll kind of stay consistent. We're going to get rid of this. And I'm going to go ahead and just keep the parentheses. See what I did? I got rid of the negative by moving this to the denominator. Then the negative disappears, it becomes positive. But just like this one, they wanted you to simplify it. Well, the negative with an even, we know that the negative will disappear. And 3 squared is 9. So the negative disappeared because that's an even power in the parentheses. You have this parentheses. And then you end up with 1/9. Positive 1/9. And then if you use parentheses on your calculator, it would tell you it's a positive 9. All righty. So again, I got rid of the negative. I flipped it. And then I squared it using our rules from our last section. D, the negative is not in the parentheses, so it stays. So this is a negative, that's from here. This is going to go underneath. Well, I hope I didn't lose you there. So to get the negative stays, it's not in the parentheses like this one. And then to get rid of this negative here, I put the 3 squared underneath. So you have 3 to make this a positive 2. You change the position. Numerator to denominator. And then finishing it, negative 1/9. So that one is a negative 1/9. And the reason the negative stayed is because it was not in the parentheses. So many little ideas. So many. It just comes with practice. You just have to practice. Let's look at E. AB to the -1. It's important that you realize that the A has a +1 exponent on it, and the B has a negative, because if it's not there, it's a +1. So the A is going to stay because we want to just get rid of negative exponents. And so to get rid of this negative, I put it underneath to the first power. They kind of split apart. And so the A stays, but the B comes underneath. And again, we don't write it with that B to the first. I just wanted you to realize that the negative, to make it a positive, you change the position, it comes down to the denominator. And then you've got that positive exponent now. That's how you get rid of a negative, is you change the position. Let's keep going. F here, t to the 5th times t to the -2. What I advise you to do is, I mean, you could get rid of this, but what I would do is use your product rule and add your exponents. 5 plus a -2, and you get t to the 3rd. And you're done. It's already a positive exponent. 5 plus a -2 is 3. So you don't need to really worry about that. Okay. Okay. Looking at G. Let's see. I think the easiest thing for you guys to do is to work in the parentheses first. And here I'm going to have the 5 stays. It has a +1. And this X is a -2, so it comes underneath and becomes a +2. The Y cubed stays because it's positive. It's not going to go anywhere. Only if it's a negative do you switch. So I simplified inside. All right. Now I'm going to get rid of my negative exponent. And what that means is everything in the parentheses is going to change positions. So it's going to become x squared over 5y cubed. It changed the position, numerator to denominator, of everything inside. So I simplified, got rid of my negative exponent. Then I got rid of this negative, because I know that negative changes the position of everything in the parentheses. So the x squared comes up, the 5 and the y cubed go to the denominator. Now I do my 4th. 5 to the 4th, 625, yeah. So here we'll go 2 times 4. I'll just put it over here. I don't need parentheses. Once you're taking care of these power to a power, you can drop the parentheses. So we have x to the 8th. 5 to the 4th is 625. 3 times 4 is 12. You know, you just have to be methodical. Parentheses, then this flips it, and then I took it to the 4th power, and just practice. Okay, let's look at this one. There's a couple of things you could do. Looking at this, I would get rid of these first. You know, by changing the position of both of them. The -5 comes up and becomes positive. The -4, it'll come down and become positive. And now we'll use our rule of our quotient rule. 5 minus 4 is x to the 1st, or just x, because 5 minus 4 is 1. So you subtract exponents when the bases are the same. for that one right there. And yeah, you know, the problem is as more upper level math, the more ways there are to solve a problem. And Pearson, if you look at an example, may have a different way here. A different way. Let's just look at it real quick. Because we don't have too much further. Here, you know, I didn't put the t underneath the t squared and then use the quotient rule. I just used the product rule. Here, looking at this, you could have taken a -4, subtract a -5, because you subtract exponents in division, and that gives you x to the first. So, you know, you could have done that similar to what we did with f. You could have done h that way and got the right answer, x. Whatever way seems easiest to you. Let's look at I. On I, these are not common bases. So what I'm going to do is just get rid of the negative exponents. Let me kind of move this up here. So here, this will come down and become positive. This will go up and become positive. And that's all you can do because the bases are not the same. You can't subtract exponents. There's your answer. Okay, let's look at J. Given this problem here, a couple of ways you could do this. First off, -10/5. These will reduce down to a -2 in the numerator, okay? And then the 5, it's a 1 in the denominator. Okay, you could bring this x down and then, okay, make that positive. That's probably what I would do. So here we have x squared down there, and we have y to the 5th. They stay down here. This one, I'm going to move down here and make it positive. And then this y stays. So all I did was get rid of the negative exponent. That's all I did. Okay, so we've got the -2, that came from the -10/5. This x to the -3 came down. This y stayed because it's positive. It's not going to go anywhere. The x squared stays where it's at, and the y to the 5th stays where it's at. Now we can simplify. How do we do that? Well, we've got an x squared and an x cubed on the bottom, and they're being multiplied. So that gives us x to the 5th. Now, the y's. All right, this brings us to a point. You could take, whenever the quotient rule says to take the numerator minus the denominator. So you could write y 1 minus 5. Just go ahead and subtract them, and you get a -4. So we have a -2, y to the -4 over x to the 5th. I subtracted the exponents, 1 minus -5. This negative, though, you'll have to bring it down. Okay. So you can actually just use the rule. Take 1 minus 5, okay, put it right in the numerator, take 1 minus 5, -4, and then it'll come down. Or you realize that here, when you're reducing these, you've got more of them underneath. So you'll, let me get another piece of paper here. Another way to look at this one. You can go ahead and do the, you can multiply those. X to the 5th. You know you have more y's in the denominator, and 5 minus 1 is 4. So you'll always place it where you have more, and then you subtract the exponents. Or you can just use your quotient rule every time. 1 minus 5 is a -4, and then you have to bring it down. Whichever way you've learned or whichever way seems easiest for you. I usually just say, okay, I've got more here. How many more? 5 minus 1 is 4. So, but you can keep using that quotient rule. This minus this. Just realize that if it's a negative, it's going to have to come down. If it's a negative. All righty. Perfect. Let's see what we got next. Now we're just going to practice. Okay. So we already know from the last section that the S is to the -5 and the T is to the -5. What I do with these is that I see if I can do anything in here, reduce, and there's nothing. So then I do the negative, which flips it. We've kind of already done one like this. Kind of a recap. And once I've taken care of the negative and made it positive by flipping those, okay, I don't think they're going to use the word reciprocal, but yeah, that's what it means. So here, I change the position of everything inside, and now I can multiply exponents. T to the 5th, S to the 5th, and that's your answer. That's all there is to it. Okay, so let's look at, well, some more terminology. We're going to talk about reciprocals, and reciprocal means to flip. So when you've got this negative outside, you're actually finding the reciprocal to get rid of it. The reciprocal, you flip it. So we talked about that with perpendicular lines. They have to be opposite and reciprocal. So if you have 2/3, you flip it and get 3/2. That's the reciprocal. And if you wanted perpendicular, you'd have to make it a negative. They have to be opposite, but this is just, so here, this right here just flips those. So the B, which didn't come out very well. So the B goes from denominator to numerator. The A goes from numerator to denominator. That's all that negative does, is change the position. And you end up, and then the N, then you can take care of your N power, which is kind of what I did here. Okay, let's practice a few more. And then we're going to look at, some scientific notation real quick. We might just kind of skim that because most of you are familiar with that. Okay, looking at A, we're going to take care of the negative because there's nothing to do in the parentheses, and it's x to the 4th over 2y. No simplifying can be done here. So here, this is going to take the reciprocal, or it's going to change position. 2y over x to the 4th to the 3rd. Now we take care of our third. 2 to the 3rd is 8. 1 times 3 is 3, using our power to a power rule. 4 times 3 is 12. So I look at inside the parentheses. Is there anything we can do? If not, then you flip it, and then you take care of the power. It happens to be a cubed. And that's it. There's your answer. Let's do another one. B. So again, I highly recommend that you take care and you simplify inside before you do anything else, before you even look at that -4 out there. But, well, it might, you see this negative here? This negative inside the parentheses is an even power on the outside. So that negative is going to disappear. So we can just ignore it. All right, so it's gone. 4. Okay, that negative disappeared. If you left it there till the end, that's fine. Eventually, though, you're going to have to realize negative in the parentheses with an even power becomes positive. This x to the 4 is going to stay. I'm just looking on the inside. I'm going to draw my line here. This y squared is going to come down. Just somewhere, it doesn't matter. The 5 stays. The x to the -1 comes up, becomes a +1, and this y to the 4th stays. So all I did was take care of the negative exponents. I'm still not done simplifying. So we have 4. This is x to the 5th. Don't need quite such a long bar. Product rule, adding exponents. 5. Product rule, 6. I simplified inside the parentheses following the PEMDAS. I'm going to flip it now because of that negative right here. Over 4x to the 5th. They both change positions to the 4th. And now we're going to take and do our 4th power. So that's going to give us, let's see, 25, 625. Kind of running into this one over here, but that's okay. 5 to the 4th is 625. 6 times 4 is 24. 4 to the 4th is 256. 5 times 4 is 20. And there you go. There's your answer. If this cannot reduce, then the 4th power cannot reduce either. So the 625 and the 256 will not reduce. Alrighty, so 5 to the 4th, and then you multiply power to a power to get the exponents there. So again, just simplify inside as much as you can before you flip and do the power. Let's do another one. Yeah, we might just do one more, and maybe we'll do D, and that'll be good. Okay, here it's to an odd. There's not a negative, so we don't have to worry about it. Let's simplify inside. We've got 2 stays, x cubed stays. The y squared comes down, so I've just taken care of the numerator. The 3 stays, it has a +1. It's kind of hard to see, but it's not a part of that exponent unless it's in parentheses. The 3 stays and the y cubed comes up. So let's keep going. Yeah, there's no other x's, so 2x cubed. Now, these are the, here, common base. 3 minus 2 is 1. Y to the 1st. 3 minus 2 is 1 over 3. I do know it's in the numerator because I have more of them. I have 3 of them in the numerator, so your answer will be there. 3 to the cubed. So let's go ahead and finish it up. 2 cubed is 8. 3 times 3 is 9. 1 times 3 is 3. 3 cubed is 27. All right, and you can always use the caret key and 3 cubed and 2 cubed to get those, or whatever your calculator is. If you ever have questions on your calculator, let me know. I don't go over calculators. Everybody has a different one, but if you have questions about it, let me know. Maybe we can figure it out. Let's do another one. D. I don't think we need to do it. All right, so here, this parentheses is cubed. So I'm going to go ahead and do that right now. So we have 2 cubed. I'm just going to write it here. 2 cubed is 8. 3 times 3 is 9. And then I can put a times here. 4a to the -3. This parentheses is a to the 10th. Hopefully I didn't lose you. I just took care of those power to a power. There was nothing to do inside the parentheses themselves, so I just went straight to exponents. So now we'll multiply here. I'm going to actually simplify the numerator. 32, 8 times 4. 9 plus a negative 3 is 6. So you add the exponents. 8 to the 10th. All right, let's keep reducing. Again, a couple of ways you can do this. One way is to take 6 minus 10, subtract the exponents. Okay. What that gives you is 32a to the negative 4. And then you'll need to realize that because it's negative, because you subtracted exponents in division, it has to come underneath. "32 stays, but the a to the 4th comes down." Or looking at this, you realize, okay, I have 10 a's in the denominator, so I know they're going to be in the denominator because I have more of them. And then 10 minus 6, I'll have 4 more. So you can look at it using the rule, the quotient rule, or reasoning through it. And you kind of use the quotient rule because you're subtracting them. It just tells you where to put it here. And then you take the 10 minus 6, the largest one minus the smallest one. Either way, you'll get the right answer. Okay, so the video doesn't get too long. Let's look a little bit at scientific notation. Now, scientific notation is a way, again, of writing very large numbers. And this number in front, most of you are very familiar with this. This has to be between 1 and 10, but not including the 10. So it could be 9.9 or 9.99. You can have a 1 because of the bar. All right. So determine if the following are written in scientific notation, following this kind of a rule right here. You look at the n, which is this. Is it between 1 and 10? Yes, it is. 3.56. You can think of it that you're only going to have one digit to the left of the decimal. You can only have one digit to the left of the decimal. Times 10 to the 14th. So that's a yes. This is a no, because you have 2 digits to the left. And also 12 is bigger than 10. Your n has to be less than 10. Here, 0 doesn't count to the left of the decimal. So you don't have any digits, so no, this is not in scientific notation. It's less than 1. It's over here. It's less than 1, so that's enough. And this one digit to the left of the decimal. And it's between 1 and 10. 9.2 is. So this is a yes. You know, we didn't really look at the times 10 to the, that doesn't matter. All right. So let's look at converting from one form to the other using scientific notation. So converting to write a number from scientific notation to decimal notation, we just need to move the decimal place. So to go from one form to another, we're moving the decimal place. What we have is we have 4.893 times 10 to the 5th. This means we're multiplying this by 10 times 10 times 10 times 10. Okay. Now here, again, in your other math classes, when you multiply by 10, multiply by zeros, it tells you to move the decimal over. So this would be the number of zeros that you got. I'm just going to write it down. I'm going to add some zeros. We may not use them all. I'll just add a few. We're going to move this over 5 times. I have 5 zeros. You move it over to the right. Okay, these are multiplying. So you move it to the right 5 times. 1, 2, 3, 4, 5. So 789,300. Okay, would be, these two are equivalent statements. Let's look at the other one. This is 4.7 times, all right, 10 to the negative 8. We know that a negative exponent means it's changed its position. So these are really not in the numerator. These are in the denominator. There's 8 of them. 6, 7, 8. All right, so it's really division. A negative exponent means that if you want to make it positive 10 to the 8th, you move them underneath. So this is 10 to the 8th in the denominator. Negative exponent, you move it down. So it's a division. And when you divide by zeros, a number of zeros, you move it to the left when you're dividing. So you're going to move it to the left, how many zeros you have, which is 8 of them. Oh, I'm not going to put the decimal there. I'm just going to put some zeros in front and move it because I'm not sure how many we need. Probably too many, but 1, 2, 3, 4, 5, 7. Oh, it happened to be right. 8. There you go. All righty, so you can see that negative exponent idea is in scientific notation. It moves it because it changes the position down below, which means it's division. This one is a positive exponent, so it would be just written all out this way. So you're going to move your decimal to the right 7 times. I don't know how many zeros I need. I'll just add some. 1, 2, 3, 4, 5, 6, 7. Close. Okay. So these two represent the same number. So that's how you go from scientific to decimal notation. Yeah, decimal notation. I almost said standard notation, but I guess they're going to use decimal notation. Okay, now let's go the other direction. Convert to scientific notation. This is a large number. Okay, it's going to look like these with positive exponents. So I'm going to move my decimal. Let's see, it's right here at the end, always. If it's not there, it's at the end. 1, 2, 3, 4 times. Remember, 1 digit to the left. How many times? 1, 2, 3, 4. There you go. There's your answer. 1 decimal to the left. And you moved it 4 times. And again, you could go back to the original. Here, I know that this has the negative exponent. All right. It's a small number. So 1, 2, 3.27, 1 digit to the left. And we moved it 2. -2. So the negative represents the smaller numbers because it's division. And if it's a larger number, it's a positive, it's multiplication. Last one. 4.26. 1 number to the left. 1, 2, 3, 4, 5, 6. -6. Okay, perfect. All right, let's look at the next page and see if there's anything here that we're not going to do the significant digits. So here we're going to multiply. Okay, let's look at the box here. When multiplying or dividing 2 measurements written in scientific notation, you must round your final answer so that it has the same number of significant digits as the number with the fewest significant digits. The rounding must happen at the very end of the calculation. So we'll talk about significant digits there. Looking at this example, we have these 2 significant digits. And so that's what we're going to want. We'll want 2 significant digits here. So we will multiply the 7.2 and the 4.3, just like we multiplied the numbers in front. So we'll take 7.2 times 4.3, and we're going to get 30.96. Now, this is not in scientific notation. I haven't paid attention to these yet, but to make this scientific, which I think we'll do right now, well, now we'll wait, times 10. So we're going to leave that there. All I did was multiply these together. We'll look at the significant digits here in a minute. You add exponents when you're multiplying common bases, and the bases are 10. 5 plus a -4 is 1. And they want it in scientific notation. So they don't want you to move the decimal over once. Okay. Now this right here, okay, that is this right here. You still have that. So I made this scientific notation. It's a larger number. Okay, so I knew it was positive and I had to move it over once. If you moved it over once, you'd come back to the original. So this becomes 3.096 times 10 to the second, because you add those exponents because the bases are the same. Okay, 2 significant digits. Right now, it looks like I've got 4. I only want 2. So it looks like we're going to have 3.1. We'll round off to the nearest tenth there, times 10 to the second. All righty. I don't want to spend too much time on this because a lot of calculators now will do this for you. We'll convert it into scientific notation, but just, kind of a little bit so you kind of understand what the calculator is doing. This might be the only step here that you may have never done before. And some of you may just say, okay, if I move it over here, I've got to add 1 to this one. Because whenever you move it to the left, then you're adding 1, because to go back, you move it to the right. I don't know if that makes sense, but if it's larger and you move it, you'll add 1 to that. But that's kind of why you're adding it. This and this are equal to each other. With a common basis, you add their exponents. Okay. So let's try a division one here. Be our last one for this video. I would take and divide these two. So 3.48 divided by 4.64. 0.75. Oh, okay. Which is also 7.5 times 10 to the -1. And so to get rid of this, you would divide and move it to the left. So we've got that. This, subtracting the exponents, so this right here is times 10. -7 minus 6 is a -13, because you subtract the exponents. So we have a times 10 to the -13. So I looked at the number in front, and then I looked at the times 10. And now we'll simplify this. Okay, they have 3 significant digits, and we have the 2 significant digits. I don't know if they would let you, they might let you get away with this, 7.5 or 7.50. maybe they would accept both of those. Okay. All right. So that's kind of what your calculator is going through and how to convert these here. And then this came from here, and then you combine those. This one up here, I had a 30, and I knew I had to move the decimal over once. And then this right here came from my tens. And then you combine those at the end, just like we would combine these two. All right, well, that's just kind of a general overview of scientific notation. We are done with that. If you have any questions, please let me know. Thank you.